Good afternoon, everybody. I hope you can hear me. I'm Robert.Fildes, the Director for the Centre of Marketing Analytics and Forecasting in Lancaster, and my colleague Nikos Kourentzes, who's also a member of the Centre, but a professor in Sweden. Now, let me give you a bit of background as we set off on this discussion of software and how we got into this question. Well, let me try to move on. Okay, what is the Centre? Well, the Centre is concerned with almost all aspects of business and organisational forecasting, mostly short and medium term, but not inevitably. Nikos and I had a foray into climate forecasting a few years ago. The Centre carries out all these topics, short courses, consultancy, but the one I want to highlight, of course, is software development, where for one reason or another, we've been engaged with organisations, discussing with them their software requirements. And these discussions form the early stages, the basis, if you will, of the report that we're giving you here. I'm still not, that's right, we've got everything working. I hope things are working from your end. Do send a message if things are difficult. Why is software so important? My background, or our backgrounds, are rather technical. I'm a statistician in my distant youth. But as we got engaged more and more with forecasting in practice, we could see that there are a whole variety of people, analysts, crucially demand planners, researchers who generated knowledge in the forecasting area. And that knowledge only became valuable if software suppliers of one form or another, they could be academic software suppliers, actually put into place the ideas. You have an original methodological idea, research, and I'm sufficiently old to have had direct contact with William Jenkins of Box Jenkins fame. And why was that such a successful innovation methodologically? Well, early on, in the late 60s and early 70s, the software became available. The NAG software, written in Lancaster as it happens, and was diffused successfully through the NAG libraries. Now, at the same time, Bayesian methods of forecasting, which are associated with the name Jeff Harrison, who was working initially for ICI and then took an academic role, were also developed. Now, was Bayesian software better or worse than the ARIMA methods of Box and Jenkins? Well, that wasn't the issue. The fact is the software was worse. The software wasn't available. So until software actually embeds the methodological ideas, preferably through some follow-up applications, and then there's issues of recruitment and training of technical staff, this original methodological research never gets into the applications area, never gets adopted by forecasting units to produce the better forecasts and the product service advantages that really are very much part of forecasting. And over a career of 40 or so years in forecasting, the facts are that actually there have been many methodological developments, and often these get into organizations very, very slowly. So what are the issues then of software? What are the alternatives? Well, first, if you're an organization, but also I suppose if you're a researcher, you've got to identify a list of requirements. In a complex organization, and let's use Walmart as an example. Walmart has, I don't know, how many thousands of stores, 100,000 products, producing forecasts daily. This is a massive set of requirements For a research analyst, however, they're going to be very different. They're very much more flexible. Speed is much less of the essence. So there are a set of must-haves for any user of software, a set of like-to-haves, and quite importantly, as I've already pointed out in the context of the Bayesian example, you need a software support source and a reliable supplier, a validated software as well, which is not unimportant. So the final stage of what we're going to be talking about today, after these first two, the requirements list, the right software, is how you can get the best out of the chosen software. For a researcher, that's perhaps rather less of an issue. But for a demand planner, working with some of the very well-established and expensive pieces of software, that is much more difficult. So we'll spend quite a bit of time talking about that issue of using software and getting the best out of software in an organizational context. So if we look at the process of organizational forecasting, you've got a series of tasks. Now, we're going to concentrate on the tasks in the oval towards the bottom. We're not actually much concerned, although we will talk a little about the role of judgment in forecasting, which is by far from unimportant. But actually the core issues of data analysis, exploratory data analysis, choosing the appropriate method, linking that possibly to information, market information, which is diffuse through some judgmental process to produce an initial forecast and revisions, and also an evaluation. So the process of organizational forecasting, the tasks that forecasters undertake are multiple, and forecasting software needs to characterize the tasks. Does it do it well? Does it do it badly? Some bits of it are very, very straightforward. Actually doing the modeling, doing the actual calculation as you would expect. Of course, many organizations still use rather less well-established routines, perhaps embedded in Excel. But if you take some of the established software providers like SAS, the software algorithms are extremely effective. So you've got a question of how you choose between algorithms and then effectively evaluating that choice to see whether it works. And finally, let me reiterate, one of the aspects of our presentation today is concerned with squeezing the extra bit out of that software, getting that software to work. Now I'm going to hand over to Nikos to talk a little more about this.
Okay. So I think before we start thinking about all the characteristics of the software that we need to cover, it's important to think about what does a forecast require us to do? What's the process around it, and how do we get to a good forecast? And in some sense, we'll first talk about it from an abstract point of view, and then we'll go through a quick case to demonstrate how putting all this in practice gives you value, and then relate that back to the software itself. So let's think about a range of different forecasting approaches you could have. You have a forecast. A forecast, of course, you're not forecasting for the sake of forecasting, but you're forecasting to support some kind of decision, some sort of operation. So based on that, you will have some available data. With this data, you can do quite a few different things. So first, you need to consider what kind of forecasting methods are appropriate for that. And the word appropriate here is a bit not necessarily straightforward, because it goes into what is also available to you. So for instance, a lot of you, I'm sure, have heard a lot about this AI and deep learning, and many people have their views about it. I can surely tell you that it doesn't solve all our problems yet. If it will ever, let's see. But the point I'm trying to make here is that typically we have a hammer and we hit with that whatever we have in front of us. And that's a bit on the selection of the forecasting methods. It's a question to make about what is available to us, and it's another question to say what is the appropriate one for the problem. Anyhow, once we have this pool of methods from which you can choose your right model, there are questions: how do you select the correct model? How do you estimate all the parameters or tweak hyperparameters and so on that are required from these different models, which eventually leads to someone doing that decision. Now, someone doing that decision is a bit interesting again, because that could be the user of the software in the particular case, or the planner or the analyst who is central to the process of producing a forecast, or it could actually be some expert who already encoded some principles in the whole thinking. So for instance, software A might choose a particular forecast following this particular methodology. The user may not have many options on how to change that, manipulate it, or even knowledge that this is a predetermined selection procedure. Now, the analyst or the user of this whole process will, of course, have additional soft information that is not hard-coded in a database. For instance, information coming from the marketing team, perhaps even direct comment from consumers, maybe reading online commentary on the product, or having some feedback, or different many approaches you can have now, especially nowadays with all the sort of scraping we do of the online sources that are out there. Of course, the forecast, as we said, is not running on its own just for the sake of forecasting. We're doing it in order to provide some support. So you may have other functions in the company or the organization who require to have some sort of input or an option on what to do with that forecast. For instance, suppose you're producing a forecast to support inventory decisions. Well, you may suggest that the demand is that much, but if the production or if the logistics cannot support that level of demand, then this forecast should be revised in some sense. So all these different aspects have to come into place. And eventually what we really want to do, we want to somehow combine this hard-coded information coming from some forecasting algorithm, some perhaps statistical or machine learning process, and all this software information. And this is essentially the task of the analyst. And if we think about some sort of resources we want to give this analyst to do this job properly, we need to provide the right tools here. And obviously the software is central to that. And the software is not central only in terms of saying, here is a set of forecasts, but it's also in terms of interface or providing the right information, feedback, and so on. I think, Robert, you want to add something here?
I mean, I think it's important to distinguish between two very different types of forecasting. One of which is the one-off exploration of an economic or marketing problem, and the other of which is or becomes routine, daily, hourly processing of data. And we'll talk about both those, but they are rather different. And of course, they do have different requirements for the software, where if you're doing a one-off analysis, you can spend an awful lot of time exploring the data, squeezing the data. Some dangers there, of course, squeezing the data to get, in some sense, the best model. For a company or an organization such as Walmart, processing these vast amounts of data, then that is quite different. But nevertheless, you want to link sensible exploratory analysis into the ongoing process.
So there are some key elements here to consider. If you want to satisfy the procedure we described before, to get some accurate forecast or useful forecasts, not necessarily the same accurate and useful here, well, there are a lot of options in terms of software. So somehow you need to select the right software. And so there is a matter of shortlisting, finding from the different vendors out there, different proprietary software that is available in the market, what actually offers, what each one of these offers. Does it do the job for what you need to get done? And at the same time, you also have all this open source community, which perhaps in a bit more ad hoc way can also provide solutions to the predictive problems. And sometimes this will work well with proprietary software or not. So there is this aspect there. The other aspect, of course, you have is, okay, so you somehow get in line and get a new software or some new system implemented. You've done all the investment. Finally, the consultants are out of the organization and you want to run with that software. Well, how do you actually operationalize that? How do you actually make sure that all the capabilities you have do actually provide you the value you're looking for? And in terms of adding this value, in terms of embedding this software in the process, there is a question of how you incorporate the judgment. We'll make not judgment a few times in this presentation because it's often something that it's ignored. Often the software development or the implementation of the software is seen as a more technical or a hardcore element rather than incorporating all the software elements of information or additional things we need to do with with the forecast. And in order to do that, it's interesting to see results from a recent survey that actually Robert did some time ago. So I will let him actually go into
Yes,
that.
I mean, this survey by Orsa Timms had been going on for many years, and the centre here got added into it to, I think, I don't quite know, somebody withdrawn, but it's quite a difficult thing to do. We identified, as you can see, 100 plus forecasting software products, tried to get response. What do these software products do? How do they actually differ? And we only finished up with 20 respondents, so it's a bit more limited than we would have liked. We classified the survey, the software, into these various types: general purpose, specialist forecasting. There are some specialist forecasting packages designed, falling somewhere between the software for the analyst and software for the organization. Of course, there's lots of very complex, diverse econometric software. Then more generally, these forecasting support systems, these software systems, SAP provides perhaps some of the most varied. They've got many different products, but you're talking about very large sums of money for those. And then finally, the open source software. The software, the survey itself is available, as you can see, on the web address down there. Okay.
So in terms of, there was a point of Excel there. In terms of choosing software, so what's wrong with Excel? I mean, there are a lot of things to say here. It really depends from one hand what you really need to get your data to tell you. If you're looking for some simple calculations, obviously the flexibility of Excel is quite great. On the other hand, the flexibility is also its problem, because we can make mistakes, we can forget to do things, or we can use the wrong formula and so on. So if we look more specifically in terms of the forecasting, if you look at previous versions of Excel, they had very basic stuff. Newer versions of Excel has more advanced forecasting modules in place. But again, there is a question here. Are they actually done in a way that they can help us get the forecast done? There are questions here of, do we have enough control of the techniques? There are questions of, are these techniques implemented correctly? Do they have the right automation that will let us do our job in an easy way and also get a reliable answer out of it? And obviously then there is the standard question of, can we really have a nice process around the data structure before and after the generation of the forecasts? Because as we all know, Excel is very easy to end up with quite massive spreadsheets that then you end up having to look of where is that formula I was looking for all the time. But critically, the point that this leads us to is that the software has to match the organizational processes. If we're talking about a small unit that requires a very flexible way of analyzing the data, perhaps Excel then is not necessarily the worst tool available. But obviously, as you have a more data-rich environment and more sources of information, this becomes less and less the case. Okay, it's a matter of, do we have a one-off case of looking at some data and getting some quick answer, or are we looking for something that's going to be operationalized and we run at a high frequency every week, perhaps every day, perhaps, and so on? This again brings a bit to the question of open source versus proprietary, because in some sense we can think about Excel as giving you a sort of an easy access to open source, in the sense that you can implement whatever you can copy from some interesting website online. And I'm not making the point that these solutions actually are not working. What I'm making the point here is that they are implemented outside of a particular process or a particular structure that enables you to do the forecasting correctly. So that, of course, leads us to a question of, what are the current issues then in getting this done? How do we have this forecast done correctly?
We see in organizations the need to choose the best approach. And I use best in quotation marks because it's very unclear quite what's meant by the best approach. More and more, will take a sample of time series. So an organization will choose to look at its own time series and will contrast the results from some statistical forecasting methods. There are online approaches, which again are free, which we'll refer to in a little more detail later. We'll run a variety of approaches. The latest machine learning method will compare what actually happened. The people running it, certainly if it's consultants or software suppliers running it, won't know what's actually happening. We'll compare the actuals with the forecasts and decide what works. That's perhaps an ideal situation. In the real world, as we'll talk about in more detail in a moment, judgment, as Nikos has referred, has a major role. That effectively, what happens is you get a forecast out from a statistical method, and it's still true to say that exponential smoothing or some variant of exponential smoothing is the most used, most available forecasting technique or method in organizations. And then people using it, the demand planners or whoever, will make some judgmental adjustments, and maybe they'll work a calculation of forecast value added, which is what value comes from that judgment. So that's the competition, if you will. You've got to agree the accuracy measures. Now, obviously, we don't know who's in the audience here today, but it's really important that you decide what an appropriate accuracy measures are. There are various methods of calculating accuracy. More often than not, in the organizations we've worked with, we found accuracy measures which are totally inappropriate. And I underline how difficult and important that choice is, because you actually want the accuracy measure to match with a decision problem. One big area of interest to retailers, increasingly of interest, an issue for Amazon, for online retailers, for example, is the problem of intermittent demand. That is to say, demand where you have an awful lot of zeros, and methods. You need essentially especially designed methods for intermittent demand, but you also need to agree appropriate accuracy measures. So when you're benchmarking an organizational forecast, you need to do a large comparative study, which in some sense replicates as close as you can the process that goes on in the organization. Most recently, there's been an academic version of that called the M4 competition, with I think 100,000 time series, a large number of time series, trying to do exactly that, looking at some machine learning methods, looking at exponential smoothing, looking at the very most basic methods. So this is an area of current research. What did we discover from this? Well, some of the machine learning methods did pretty well, it would seem, but maybe I'm jumping ahead of myself. Now, what methods are actually used in practice? Well, as I've said, it's horses for courses, but actually, it's still horses for courses. Actually, what goes on in organizations? Well, some of you will be researchers listening to this, perhaps even the majority. But if you look at these various surveys which have been done since 2000, there are some earlier surveys as well, what we find is that judgment is much the most important, or most common, I should say, aspect of the different approaches to forecasting, and more particularly, adjusting a statistical forecast is the key method that organizations use. So the picture that we painted earlier on had in it two elements. It had a statistical forecast, it had the judgments made in modifying that statistical forecast one way or another, and also a set of alternative forecasts, advice, if you will. And as the slide points out, this is not just about demand forecasting. This happens in macroeconomics. So I did a bit of a discussion with somebody who was a key forecaster in the Bank of England. And they had a process which essentially had a complicated econometric model producing a forecast, but this was modified, and more particularly the prediction intervals were modified by judgment. It applies in weather forecasting as well. So judgment then is a key component. So when you're thinking about a statistical model, you've got to look at potentially its application of statistics plus judgment. And there are interesting questions about which statistical methods are most amenable to judgment. Now, I'm going to pass this now back to Nikos to talk in more detail about the characteristics of methods.
We're given a bit the setting, and what I'm going to do is slowly jump towards a case to just demonstrate how important it is to go through these steps. So let's think about how to get the forecast done. So we have some data, we have an objective, something to forecast. Well, we need some benchmarks. We first need to have a feeling of how difficult or how easy is that time series to forecast. And typically we can do that using some basic extrapolative forecasting models. Exponential smoothing comes to mind quite easily, ARIMA models and so on, that almost all dedicated software or open source packages offer. That of course requires some selection of the appropriate model form, of the selection of the right parameters and all that stuff that you can either have some sort of support from your software to do this manually, or you can have some automatic procedure implemented. And if you have a bit of a more richness in your data, you may be able to produce some causal models. Importantly here, causal models are typically quite pleasant to us because they give us a nice mechanistical understanding of, okay, this is why my forecast is going up or down. However, we often find once we do this horse race that before Robert was mentioning, often extrapolative forecasting is at least as good, if not better. At the same time being simpler and much cheaper if you think that you don't need any additional data. But anyhow, if you're going to go for causal models, some of this data will be internal, for instance, promotional plans, pricing policies, and so on, or it might be external. It might be, for instance, as we mentioned before, the example of sourcing online for consumer behavior, or potential calendar events, special events, and so on. And again, supplement the expert information to eventually get your final forecast. So let's jump to a particular case. I'm going to describe here the overview of the steps and what was the result from a particular case we worked a few years ago with a center here. And in a few slides, you will see the company name as well. But just to give you a bit of a feeling, initially there was an SAP implementation, and you can see the SAP current here with the percentage error. Well, the first step for us is to have some benchmarks. And the benchmarks here can be very simplistic techniques like a naive forecast, or other software packages that can provide some automatic forecast through some expert system. For instance, Forecast Pro in this particular case. Now, we want to make sure that if we're going to suggest something in the current system, obviously it will be better than a very simplistic forecast to just copy the last value in the future, like the naive. Or if we're going to say we're going to need to change the system and you need to invest that much time and resources, let's make sure it has a better effect than something cheaper alternative. So that's for us the first steps. Let's make sure that we have a good understanding of how difficult is the forecasting problem and have a way forward. And in this particular case, we used some internal benchmarks and some external benchmarks in the shape of Forecast Pro. Now, we mentioned before that obviously we have the data that is quite easy, like past demand, for instance, any kind of promotion information and so on. But there is a lot of adjustments that are happening by the experts, the demand planners in the particular case. And it's important to have an interface or a procedure there to evaluate how much value these different adjustments do. For instance, here, what we have in the graph, we have a statistical forecast and a final adjusted forecast. So what would happen would be that you would have the software somehow produce a forecast. And in the previous slide, we saw that you could revise a bit the procedure so you get the best out of the existing software to get the most accurate forecast possible there. Then you would have that forecast, and then experts would look at that forecast and superimpose their information from additional information, let's say from meetings, other teams, and so on, but also their market intelligence, and try to improve it further. And what we see here is that often they could add quite a bit of value. Now, in order to be able to do that properly in an operational setting, you need to provide to the experts some feedback and say, in this particular case, you're adding value, or in this particular case, you're not. Or for instance, last time you had this particular example, say, for instance, some special event happening, or a launch of a new product or something like that. This was your previous adjustment, and this was how successful or not that adjustment was. So you need to provide some sort of a guidance. And in this particular example we had, the software they were using could not provide them a direct interface and a direct feedback on what the experts were doing. So we had to do this as a post-processing step in some sense. But you can see here from the graph at least that you could have substantial value added by just enabling this step. In case of large adjustments, which of course it has been seen several times in the literature that there are several issues with these adjustments, if the experts were guided properly, you could have more than 100% improvement in the error. Now, so if you think about improving the whole process, what do we have? We start from a current implementation or lack of, if you wish. You have some software you have to work with, supposing you have already chosen. Then you have to look through that and see what are my options? What can I do from statistics or machine learning to get the best out of the database I have? Then that leads to some sort of a procedure to say, all right, in this particular type of time series or products or categories or whatever, this is how you're going to do the forecasting in terms of choosing the algorithm, parameterizing the models, and so on. Then the other step that you have to take into consideration is superimposing this judgment. There are all these behavioral aspects that we can put in the process and get further improvements. Now, in the particular example in Sanofi Aventis, what we ended up suggesting was essentially to lessen the number of adjustments and only focus on the ones that were adding maximum value. That essentially for them meant, well, fewer adjustments. That meant fewer meetings. That meant all their monthly SNOP meetings were essentially much leaner and faster. The improvement in forecast accuracy resulted in about 3 million of savings. So, and that is the net effect of both improving the statistical side and also enabling the judgment to be improved as well. And obviously all that then leads also to improved service to your end customers. So doing these steps properly can actually have a substantial impact. So what are eventually the factors then that will lead us one way or another? Well, first of all, what kind of data do we have available? What information is there for us? Is there some information that I can quantify quite easily and put it in a database? Is there some sort of software information that is a bit harder to put in a regression model or I need some more advanced techniques perhaps? I have to think about, in terms of the software, what kind of software do I have on my hands available? What can I potentially easily access? For instance, my software, does it allow me to quickly draw upon open source solutions for a particular problem? Sometimes yes, sometimes no. There is a matter of what is organizational culture as well. Is it an open culture that you can easily get some external help, for instance? That might be a software that's not, let's say, centrally approved, might be an open source solution, or just an external expert to help you set up the existing process. So all this feeds into the organizational forecasting expertise. Now, once you have that, of course, that gives you a bit of the, let's say, the scenario upon which then you can consider, okay, how do I go ahead and forecast this particular product or item? Is it now mainly statistical, quantitative approaches? Is it judgment because it's a very new product, I don't have some prior information, or potentially I have prior information, but I haven't identified through analogies, some mixed approach? How easy or how difficult is the forecasting I'm trying to do? Am I in a very competitive market or am I in a very stable market? Just to give you a bit of an example, when we're talking about a 90% accuracy, in some cases it might sound great, in other cases it might be actually a really bad accuracy. Thinking about, for instance, forecasting in a retailer setting, a particular product, 90% accuracy would be quite nice to have. But thinking about, for instance, forecasting total electricity demand of the country, just 90% accuracy is terrible. So it's always a matter of context.
Could I make a point about organizational culture? Because we're in a time where organizational culture, at least large organizational culture, is changing quite a bit. And the prevalence of data science units, the enthusiasm for artificial intelligence, machine learning methods, has meant that these methods are much more acceptable than they would have been perhaps 5 or 10 years ago. The danger is that the methods are inappropriate. They're sometimes appropriate, sometimes wholly inappropriate. And the horses for courses competition slide that we saw a few moments ago is the way that you need to tackle it and ask the core question: is it adding value one way or another?
Absolutely. And this is eventually going to the very final point, because if you're going to involve experts in the process, these people will get a salary for doing this job, and they have to accept the forecast that the system provides. If not, then they will always try to somehow take ownership of it. And that's the problem. And that's one of the issues that we see also with more advanced forecasting techniques. It's one thing to have your data science group and say, let's develop the best we can and then implement for the rest of the organization. It's another thing, the users, to have an understanding of what this thing is doing for us. An interesting project we're trying, for instance, to get together with the group in Sweden is we don't have the name fully yet, but something along the lines of trustworthy AI, trying to sort of give to the user an understanding of reliability and what on earth is happening in there, so they can understand it as simple as potentially an extrapolative forecasting technique. Now, having all that in mind, we can finally go and talk about what are the interesting dimensions we should look for in the software. Obviously, there are issues of hardware requirements and so on. We won't go there into too much detail, because eventually this really comes down to what are the other characteristics you have. You have issues of data handling. Are we having some sort of a centralized repository for the data? How flexible is to introduce new data? Is it cloud-based? Is it not cloud-based? Does it integrate well with other software, other languages perhaps? For instance, a lot of the proprietary softwares are now going in the direction of, we will provide some infrastructure and some interface, and we will allow a lot of open source solutions to come into play. Other aspects is, do we implement best practices from the forecasting research? For things like, for instance, using rolling origin evaluation, running a forecast several times on test set, so we don't have just one measurement of how good or bad is our forecast, but multiple, so we can be resistant to particularly lucky or unlucky instances. Do we have access to the appropriate error measures? Robert before mentioned the aspect of error measures, and using different metrics will give you different answers. Some of the metrics are appropriate for a problem, some other metrics are appropriate for another problem. So the question then is, does your software provide you the metrics that you need for your particular case? And sometimes you need more than one metric just because you have to deal with more than one problem, obviously. Does it offer you easy benchmarking? It's one thing to say, I have a fantastic technique and it gives me a good forecast, or at least I hope so. And it's another thing to say, here's your fantastic forecast, and here are 5 benchmarks you can compare directly and see how good is actually your technique. Does it add enough value to make the point that I can accept all this additional complexity because I have all this gain in accuracy? Things that should become quite straightforward nowadays, but they're still not. Things, for instance, like prediction intervals. If we really think about forecasts, we want to know how confident we're in this forecast. It's not about the point prediction, it's about the intervals around this. Or things about multiple seasonalities. We have more and more high frequency data. We look at daily data, hourly data. We cannot model these things with implementations that are 30 years ago. They just could not handle the data structures. Other innovations like hierarchical forecasting, a particular research interest for me, which is essentially saying you're forecasting at the disaggregate level, let's say stores queue level, and you're forecasting also at the warehouse distribution center level. Let's make sure that these forecasts are coherent. That means they agree with each other, so any decision making is aligned. Or aspects of judgment, as we said before. We mentioned through this presentation already enough times judgment, and we hope by now it's becoming quite clear that if we don't support that through the software, at least in terms of how we present the information, at least, then you're not getting the maximum out of it. Aspects of explanatory analysis. So you have some time series. What do these things contain? And there you can go to different techniques. And here we just list a few of them. And the same goes for the forecasting methods. We don't need to go detailed one by one, but we're just providing here a list of things that one should consider Do I have the options, or am I just locked to one or two things that may or may not be relevant to me? And eventually, it's becoming a more and more common question is, do I really need to buy software, especially when things are so dynamic and things change all the time, or should I go open source? Well, there are a few things here to consider. First of all, open source is not zero cost, in the sense that someone needs to provide you the support. If something breaks, someone has to take care of it. And myself being an author of several open source softwares, I can tell you that I don't have the kind of availability that an IT team would have in order to support queries or new features or perhaps potential bugs in the code. There is issue of licensing. There is some what I like to call open source ethics, which is if you're going to rely on open source, then somehow we need to make sure that this community keeps on working. Forecasting open source research is a bit less developed, let's say, than things like operating systems, that actually their big tech companies provide resources to the community so it can keep on flourishing and improving. But here universities are central. And in some sense, that's why we're also doing this webinar, because we feel that the universities and industry should actually have a much closer connection to this aspect. There are aspects of quality implementation. It's one thing to say, here is my fantastic new innovative solution. Does it scale up? It's one thing to produce 10 forecasts for my academic paper. It's another thing to produce 1 million forecasts for a supermarket to run on a daily basis. On the other hand, typically, because these are research-based results, they will be more on the state-of-the-art side, at least when they're released. Are they maintained further on?
Could I add something to that? Which is a curious one, but it's worth highlighting that, in a sense, not all algorithms are made equal. Not all software code is equally valid. And for many years, I don't know the state of play now, ARIMA methods of Box and Jenkins, different codes produced quite dramatically different answers. If you take the machine learning literature, I suspect the validity of those codes can only be demonstrated not through the codes themselves, although there's obviously some logic checks there, but through the results replicated in a variety of circumstances.
Yes, and that often has been one of the motivations for us to actually start developing these open source solutions. Here I will list some of those that the teams here have worked on. And often the motivation was not just to say, okay, this is something new, let's make it easily accessible to others, but also we wanted to have full understanding and control of the different settings. Let me highlight, for instance, the smooth package here that is developed by Ivan, a member of one of our colleagues here. And the initial thing behind that was to just provide to the user all the different options that one might want to have. Of course, then that leads to the question of, if I have all the options, is that a good thing or is that a bad thing? Well, restricting the options after a point, once you have found a good setup, restricting the options is not necessarily a bad thing, because users like to tinker, and if they understand fully what they're doing, that's great. But if there is a lack of expertise, well, from one hand, that calls for training, but from another hand, then that also leaves a lot of potential for mistakes and errors. Going back to this whole point we made before about Excel, flexibility can be both a good and a bad thing. The interface is also quite important here. We have to consider, who are the users? What do they need from the interface, or what kind of needs? Understandable or clean or easy to use. If you really think about it, the interface really encapsulates the whole procedure we have described. What's the logic behind coming from data to the final forecast? What are the steps, for instance, we follow for exploring, choosing the right model, evaluating that it's the right model, and so on. So, for instance, here are some standard omissions. There is no interface for exploring your data, or it's very limited. Diagnostics of the forecast are very limited, providing feedback to users for a good or a bad choice. You get a particular result. Is it because you're great or because you're lucky? It's actually a straightforward question to ask if you do the analysis.
You had the reference to error measures. Sometimes some major pieces of software don't let you get your hands on the errors and essentially calculate only one inappropriate error measure, which is a real serious mess.
Absolutely. And just as an example, and we won't stay too much on that, there are different interfaces for different tasks. For instance, here we have an example. And actually, this is a part of a research project we're doing to sort of understand how to best present soft information for the users, like marketing information in this particular case. Or here is an interface that is about training users to understand how a particular forecasting technique works. Very different interfaces with supporting different needs. So again, what are the needs that the software should satisfy for a particular organizational task in order to think about what kind of aspects or tools we need here. One other aspect then that brings us almost close to our end is thinking about forecast as a service. What if we don't have an internal software? What if we rely to some external organization or institution to provide us this forecast? And as an example, we have here Amazon Web Services, for instance, or specialist consultants or companies. Well, the question then here is essentially what kind of communication we have with these kind of external sources. Is there transparency in the forecast? What is the associated cost of doing this forecasting? There are two aspects here on the cost. It's not just how much do I pay to get my forecast done, but it's also how much the organizational culture I mentioned before, all the additional information that our experts have is related to this external source, and potentially how this feedback of this information being used correctly or wrongly goes back to both the experts, the external experts, and the internal users. So there are these aspects there that, yes, from one hand, you can call on expertise that is scalable, that is, these people, ideally, you would expect them to have a much deeper understanding of the forecasting problem, but on the other hand, they're far more removed from the organization than the in-house teams. So there is this compromise and challenge there.
I was thinking, is it Google who provide online services?
I think quite a few of them nowadays, yeah. Google as well, yes.
You can't rely on the methods that are adopted there to be validated. So again, you would have to carry out a costly validation exercise.
So bringing everything together, it's a question of, if you have your problem at hand, what are the must-haves? What would we would like to have? We would probably not have everything in a software solution, but at least let's make sure we get the critical things implemented, or at least available to us. There are questions of technical requirements. For instance, again, scalability comes into mind here, or what kind of information can we use? In passing, we mentioned a few times using online consumer behavior. That often will require textual data being processed. Is that something that software, for instance, has? Robert just made the point about validity of methods. Can we do this comparative study and see actually, does the software do what it's supposed to do? Does method A give what the method A should give? Questions of support, and of course, eventually, there is a price tag associated with it. The price tag can be direct, I pay that much for software, or indirect, I need to pay that much for consultants, in-house teams, training, whatever it is. Just to finish off, some resources that you may find helpful. We provide here the links of our groups with different expertise and background. So, for instance, you may have already gathered from the tone of the presentation that the Marketing Analytics and Forecasting Center here has a very good history and expertise in terms of solving business forecasting problems, whereas the Swedish lab has more expertise in terms of the artificial intelligence, machine learning techniques, more in industrial applications. We have here a list of different packages for R. These are open source, implementing either novel solutions or re-implementing some of the standard solutions, but giving to the user some, if you wish, more novel or extra features. There are research blogs. I point here mine, but many academics have the research blogs, and there you can find either free copies of their papers or perhaps easier explanations of their papers, examples, and so on. We have, together with Keith Ord, a book out that is trying to sort of put all this in some understandable manner. Perhaps the interesting thing about this book is that it also comes with our material to support the different exercises and notes we're making in the book, but also there are now some free chapters online So you can get at least the basic understanding of the forecasting process and all that stuff. You can download all that for free and figure out in more detail what's going on. So coming to a close, Robert, maybe?
Yes, I mean, what's all this been about? Well, obviously it's been about software, but it's also perhaps more originally been about the need to match organisational and processes and the individuals concerned, including the decision requirements of the problem, the data skills, the data resources and the people skills that are available. The fact is that there aren't that many people who know very much about forecasting, and that includes the software suppliers. So in the previous slide, the technical expertise that will support the software decisions is a crucial component. There is an issue about the quality of the software, not just whether it looks nice. It's still the case that one or two products don't look particularly nice at all. But the fact is that the models may be inappropriate. They may not work properly. They may not be benchmarked appropriately. There may be segmentation procedures which don't work properly. This all sounds a bit scary, and in a way it is, that the people skills that you can draw on are an important part of the selection and use problem. And the final point, and I won't go into it in any more detail, the managerial interventions. Very few pieces of software support managerial intervention, and yet the S&OP process, the sales and operations planning process, is a crucial part for most demand planners in their organizational setting. And that means soft information has to be recorded one way or another and injected into the forecasting support system to deliver the final forecast.
I think with that, we come to close the presentation, but there is the Q&A option, and already there are some questions there which we will try to go to. So if you have any more questions, please post them there while we're reading what is already in place. Right, there are some, there is one question that is detailed on the error metrics. This is actually a quite big discussion, and I would avoid answering a yes or no. I don't know if, Robert, you follow that suggestion, but one thing that I would certainly say is that we nowadays have a good grasp of what each error metric means and does for the data. So it's not just picking an error metric to have an evaluation of a forecast is accurate or not. It has also to be, how is that forecast used? Is that forecast used for instance, supporting inventory decisions? Then perhaps you need a particular style of metric. What is the forecast horizon that is relevant? There are certainly some error metrics that we would always recommend against those. MAPE is fine in that sense. Symmetric MAPE is a bit more contentious topic. We won't go there. But I think to answer the question about what error metric would be good is something better than weighted MAPE that is quite common in practice. Yeah. The answer is yes, but it would be hard to say this is the only metric to use. The metrics, like the forecasting techniques, are designed to solve particular problems, and I would suggest that there is not one superior one.
The textbook that we've referred to that we wrote spends a lot of time on error metrics because it's such an important point. And so there's one reference point, and you can download a PDF file of the textbook and so on from the website. You'll get more details through the email after the end of this. The other point to be made is that the International Institute of Forecasts has an applied forecasting journal. It's not an academic journal. It aims to, in a sense, respond to questions like that. And the topic of error measures has a special issue available on that very question. So important, crucial, in fact, and if badly done, can really misguide you in the wrong directions.
Another question I have here is about low volume forecast, like intermittent demand. This is a particularly difficult problem, and I have done personally quite a bit of work on that, but a lot of our colleagues here have also done work on this. I will not say that there is one good or one bad solution. Again, in some sense, answering like a politician here, depends on your problem. But what I will say is
Better
that
be an honest answer.
this is somewhere that most of this, at least commercially available software, are lacking. The open source solutions in this matter are perhaps quite a bit more advanced, mainly because the research has advanced substantially over the last years. So it's a matter of how fast software companies implement the latest solutions in their proprietary software. And if you want the starting point that we mentioned in previous slides, I'm sure the slides will be available at the end, two packages that the center has offered on that matter. And now, in terms of using, there is another question of how do we evaluate errors, accuracy of forecasts? Well, if it's a matter of choosing, let's say, a new forecasting technique or making sure that what is in place is good enough, what we would normally do is we would hold some data aside and then pretend we never had this data. Use all the other data to train, select the model in whatever best procedure we have, and then produce different forecasts. Now, we do that with our selection of methods, and then we can have sort of a competition and say, right, method A or method B or whatever is the best in this particular case, or they're about the same, it doesn't really matter, and so on. Again, this is not an easy topic to discuss over a couple of minutes, and I think, as Robert mentioned before, there are a lot of online resources. The book we mentioned also explains that in detail. In fact, I think that's one of your main research contributions in the past years.
Yeah, I mean, one point is if you're trying to choose between method A and method B, using a relative error measure, which can literally contrast the errors with method A with those in method B, is an effective way, and much more effective than standard methods.
Another question is, again, related to how to choose a forecast procedure and approaches. Well, I will refer to one of the previous slides on that one, that we had a framework on thinking about what kind of data is available, what kind of software is available, and so on. There is another additional point we'll make here, is that forecasting is a research area that has more than 50 years now or so of active work. And initially it will be more like a heuristic approach, but I think that nowadays we can be quite confident that there are a lot of sound principles out there, and there are good resources, good papers that explain how. Perhaps one extra point we didn't make in the presentation was that often it's not a matter of just choosing one method, but it's a matter of combining some of the methods. And this combination has a lot of power into it because, well, first of all, it mitigates the issue of choosing wrongly, but secondly, it brings together additional information. Now, the other question we have here is about essentially the scalability. It's one thing to have a very elegant solution, perhaps in an R or Python environment. It's another thing to be able to then put that in a production environment where you have multiple number of SKUs, different time series, and so on. Now, this has two aspects. First, the scalability. The other aspect is the reliability of it. I would argue that these are not necessarily answered in the same way. Scalability is just a matter of, well, you either get a better implementation or get more processing power. And after a point, it's cost trade-off. But the reliability is a very interesting question, especially for us academics, I would say. It's somewhat connected to the previous points, that different procedures of picking the right model or combining the right model will provide you much more reliable forecast. And that's where the benchmarking is very critical. We're not talking about choosing a particular model for everything. We're talking about having a process in place that for the right time series will choose method A, for the right time series will choose method B, and for another group of time series may say combine both.
In a sense, what you're trying to do with the choice of method is to first identify a short list of alternatives, and there'll be some basic benchmarks. Let's suppose we're talking about univariate time series just using the past history, and one benchmark will be the ETS package in R that's readily available, exponential smoothing effectively, and you will essentially consider some machine learning methods these days. If you're looking at a wide variety of applications, it depends on who the users are. Machine learning is still pretty complex. So identifying a range of methods and then trying to associate a method with a particular class of time series. That is a tricky issue. You know, this is into research issues. Common sense will take you a fair distance. So, for example, a decision: is the series trending? How seasonal is the data? Is there multiple seasons? And certain methods are appropriate for multiple seasonality. Other methods, say Box-Jenkins, is not particularly appropriate for multiple seasonality, although it can be used. It probably shouldn't be used. So there will be a short list of methods, and then essentially you're going to try and match the method to the data series by using out-of-sample tests. So it's quite time-consuming.
One last quick question we got here, and with that we'll bring it to a close, given that we're exceeded our 1 hour. It's a question about a very particular question about new product forecasting and all the packages we have there, the Fusion package. The question is if it can predict both plateaus and subsequent decline. So essentially the product life cycle. The answer is yes in terms of technicalities, but of course this comes always with the caveat that new product forecasting and life cycle forecasting is a very difficult task. You won't expect here to have errors of 5–10%. You're expecting to have much higher errors. So as always, the longer you want to forecast in the future, the uncertainty increases. And we did make that point in passing. It's not about the point forecast, it's about the uncertainty around the forecast.
Yes, so there was one question, and I appreciate we've got to close, one question about that, about whether when you're forecasting percentiles, a service level of 90%. So you might try and forecast the 90% percentile. Alternatively, look at the distribution of forecast errors. The latter is probably better. Yes.
We're happy to take more questions. Our contact details are on the last slide, and I'm sure you get the slides there. So in some sense, we're doing all that because we do want the interaction with all the communities of researchers and practitioners. But let us thank you for your time, and I hope you found that useful.
Good.
Thank you.
Enjoyable, I hope, anyway. Bye.
Bye.